Hi there. We looked today in class at applications of systems of linear equations, and so I selected 4 from our notes to demonstrate what we discussed. The 4 I've picked are numbers 5, 6, 7, and 8, although of course you're more than welcome to do the other examples to help practice these ideas. But we'll go ahead and start here with number 4, which I've begun already. Number 5. Number 5 reads, an algebra test contains 38 problems. Some of the problems are worth 2 points each. The rest of the questions are worth 3 points each. Perfect score is 100 points. How many problems are worth 2 points? How many problems are worth 3 points? Okay, so as I read through this problem, through this word problem, I notice that I have 2 totals, and I've circled those 2 totals, 38 problems and 100 problems. I also have 2 unknown quantities, 2 points and 3 points. Okay, 2-point problems and 3-point problems. Well, as I read through this problem, there's nothing really that specifically relates 2-point problems to the 3-point problems. But I do have these 2 totals, and both x and y are contributing factors of the 2 totals. And so that for me is already going to remind me of our Unit 3 equations, which are standard form equations. And so you see the 2 that I've written out here. The first one is for that 38 problems, and if you notice I've done x and y equals 38. The reason I did x plus y is because if x represents my 2-point problems and y represents my 3-point problems, the combination of the 2 is what's going to be how many problems I have, right? Those are the types of problems on the test. So if I have 18 2-point problems, then I've got to have 20 3-point problems. If I have 20 2-point problems, I've got to have 18 3-point problems. Right? But the combination of them has to make 38, and so I went ahead and added them together. My other total is 100 points. Right? Well, the 100 points is related to their point value, and so in this case, I've gone ahead and assigned the point value to my x and y. 2 for the x, because my x is representing my 2-point questions, and 3 to my y, because that's representing my 3-point questions. And their total, their combination, should be 100 points total. Okay? So now we're to the point where we're going to be able to solve these, and we're going to use the same ideas we learned in 4.2 and 4.3 with substitution and elimination. And we're going to look at, well, how could I figure out what x and y in fact are? It is your choice how you would like to solve this. This particular problem really wouldn't be too bad to solve either as substitution or as elimination. So it really is going to be your personal preference, but I'm going to go ahead and solve this one with elimination, just because I noticed they're both already in standard form. So I just need one of them, to either the x or the y, to have the same number but the opposite sign. And so I notice here that my x is 1 and my x is 2, which means I'd really love this x up here to be -2, so I could have -2 and +2, or my y's, I notice I have 1 and 3, so I'd really love it if my y up here could be -3, so I'd have -3 and +3. It's your choice. I'm going to go ahead and do the -2 idea here. -2, -2, -2, like that. Okay, and so now I have 2 new equations. I have -2x minus 2y equals -76. And then the other equation, which I actually haven't changed, so I'm just going to rewrite it here with the other one. Okay, once you have either the x or the y with the same number but opposite sign, you're going to add down. -2x plus 2x is 0. -2y plus 3y is 1y. And 100 minus 76 is 24. So I know I have 24 y's, or 24 3-point problems. The question then is how many x's do I have? How many 2-point problems do I have? Well, I'm going to take this y equals 24 and substitute it into any of the equations. I'm going to go ahead and substitute into this top one, because that looks a little friendlier. X plus not y, but 24 equals 38. Well, then if I subtract the 24 over, I get x equals 14. And so I know I have 14 2-point problems and 24 3-point problems. Okay. Okay, so let's go ahead and do another one here. Example 6 says, Ashley has $9.05 in dimes and nickels. If she has a total of 108 coins, how many of each type does she have? Again, I'm noticing that this is probably going to be a standard form, or it's like two standard form equations because I have two totals and two unknowns. I'll go ahead and call them X and Y. X for dimes, Y for nickels. But the dimes and nickels are not specifically related, and so I'm going to be setting up two standard forms. We have our $9.05 equation and our 108 coins equation. Okay, so what are the two equations going to be? Well, the 108 is the total number of coins. And so that's that combination again, like the problem, or the points problem from before. The number of dimes and the number of nickels together have to make 108. And so that's what I'm going to go ahead and show here. I'm going to say that the number of dimes and the number of nickels, if I add them up, need to equal 108. $9.05, though, relates to the quantity, the monetary value of dimes and nickels. And so I need to reflect that. Well, dimes are 10 cents. And so I'll go ahead and write 0.1x for 10 cents. And then nickels are 5 cents, so 0.05y. And there's my other equation. At this point, again, you can solve it however you want. I'm going to go ahead and choose to again solve it using elimination. Now here's where you have a choice to make. You could, if you wanted to, multiply the bottom equation by like -0.1, for example, to get them to match up, or -0.05 if that's a preference. Personally, I always like to get rid of my decimals. Okay, so I can get rid of my decimals by multiplying by tens, because each of these spots represents a 10th spot. And I notice that the largest decimal, I should say the most decimal places I have are 2, right? I have 2 decimal places here, which means, ideally speaking, I'd really like to start with just multiplying every one of these numbers by 2 tens, which is 100. Okay, 10 times 10 is 100. And if I multiply them all by 100, that's what's going to clean up my decimal place a little bit. So 100 times 0.1 is 10. 100 times 0.05 is 5. And 100 times 9.05 is 905. And if you notice really quickly here, when you're doing that, when you're multiplying by 100, what you're doing is moving this decimal place twice. But to maintain equality, remember, if we move one of them twice or multiply one of them by 100, I need to make sure I do that to all of the others, again, just to maintain equality. And so this 0.1, when it moves twice, because I'm multiplying it by 100, that's what gives me that 10 over here. And then I'm going to go over and rewrite this bottom equation, x plus y equals 108. So again, you don't have to take that step. It's just I personally like to, just because I like to not have to work with decimals. So at this point, I'm going to go ahead and make either my x or my y to be the same number but opposite sign. I'm going to go ahead and choose to make my y's match. I notice my top one's +5, so I'd like my bottom one to be -5. So I'll go ahead and multiply everything by -5 here. When I do that, I now have a new pair of equations. The top one, 10x plus 5y equals 905. And my bottom one, -5x minus 5y equals -540. Okay. So now that we're there, we can go ahead and add down. 5 minus 5 is 0. 10 minus 5 is 5x. And 905 minus 540 excuse me, sorry, is 365. And then divide that 5 over, we get that x equals 73. Okay, once we're there, we can now take it, plug it into any of our equations. I'm going to go ahead and plug it into this bottom one, this x plus y equals 108. When I plug in 73 plus y equals 108, my y, I can solve for my y by subtracting the 73 over to the other side, and I get y equals 35. And so I know then that I have 35 nickels, because y represented my nickels, and 73 dimes. So 2 more here. Example 7. Example 7 reads, the perimeter of a parking lot is 310 meters. The length is 20 more than twice the width. Find the length and width. Okay, so these last 2 are going to change slightly from the prior 2 because as I read through example 7 here, I notice I don't have 2 totals anymore. I still have 1 total. I have the perimeter of a parking lot is 310 meters. But my other facts are what actually relate my 2 unknown quantities. I don't know what my width is and I don't know what my length is. And so I'm going to go ahead and call my L, or my length L, and my width W. And so while one of my equations is still going to be a standard form, because I have this total 310 meters, and that's going to be what I'm going to set my perimeter equal to, 2L plus 2W equals 310. My other equation is going to instead relate us back to Unit 2. In Unit 2 we looked at calculating, or looked at writing function rules in slope-intercept form, or more along the lines of slope-intercept form. So as I'm looking through the second sentence, I see the length, and so I'm going to write L, is, remember back from Unit 2, is means equals, 20 more than, and so I'm going to go ahead and add 20, and then twice the width, which is going to be 2W. And now you're back to a systems of equations. It's your choice whether you want to use elimination or substitution. I've demonstrated 2 eliminations, so let's go ahead and do a substitution here. The other reason I'm going to choose substitution is I notice I already have the L equals that I need for substitution. And so this is already in that substitution form. So I can take that and plug it into my L, which sets up this new equation. 2 rather than L, I'm going to write 2W plus 20 plus 2W equals 310. And now just like we did in 4.2, we're going to go ahead and solve. We're going to distribute first, and we get 4W plus 40 plus 2W equals 310. Then we're going to combine like terms. 4W plus 2W is going to be 6W. We'll subtract 40 from both sides. We get 6W equals, oops, sorry, that should be a 6. 6W equals, and 310 minus 40 is 270. And then when you divide that 6 to both sides, you get W equals 45. And so then you're going to plug that 45 back into any of the equations. This equation here, the L equals, is going to be a prime equation to plug into though, because it's already in the term, or in the form L equals, and so we can literally just plug the 45 in. We have L equals 2 times my 45 plus 20. 2 times 45 is 90. And 90 plus 20 is 110. Okay? And so then that's going to be my answer. I know that my length is going to be 110 meters, and my width is going to be 45 meters. Okay. Last one reads, the sum of 2 numbers is 112. The smaller is 58 less than the greater. Find those numbers. Okay. Well, sum, remember sum means addition, so we have 2 numbers, x and y. Is means equals 112. And then the smaller, I can make my smaller either my x or my y, it doesn't matter, so I'll go ahead and make it my x. The smaller is means equals 58 less than, so we're going to subtract 58, the greater, which will be my y, and then find the 2 numbers. Again, you can choose which one you want to do. I will again use substitution, since I already am in the form x equals, and so I'm going to take this y minus 58 and plug it into the x's spot right there. This gives me y minus 58 instead of x, plus y equals 112. If you could distribute, you would distribute, but in this case, I mean, there's nothing to distribute, so I can go ahead and drop those parentheses. Then we'll combine like terms. Y and y make 2y. And we're going to add that 58 over to the other side. We get 2y equals 170. And then divide by the 2, and you get y equals 85. Okay, well, if that is one number, then to find the other number, I'm going to go ahead and take this 85, plug it back into any of the equations. I'm going to go ahead and plug it into this x equals equation. X equals not y, but 85 minus 58. And then if you do that subtraction, x is going to equal 85 minus 58 is 27. And so those are my two numbers. Okay? So good luck, and there you go.